Hi everyone and welcome back to the multiverse of 100 plus data science project series. In this video, we're going to discussing about the crop recommendation system using Python and machine learning. And also we are trying to building and web applications using Flux. So let's have a look at demo first. Well, so this is a demo application built by using Python and Flux. And you can see here it having some text input. So what I can do, I need to giving here just like nitrogen, the phosphorus, the potassium, the temperature, the humidity, pH, and also rainfall. So let's give here some random value. Let's say 14, let's say 15, let's say 16, temperature let's say 25 degree Celsius, and humidity let's say 200, and pH let's give it here 7, and rainfall let's give it here 230, and let's click here to get recommendations. And you can see apple is the best crop to be cultivated right here. This is how the crop recommendation system actually works. Now in this tutorial you try to building this application from the scratch. So बिना किसी देर के हर हर महादेव बोल के start करते हैं tutorial. In order to building this crop recommendation system, we're going to collect the data from the Kaggle. That's called the crop recommendation dataset, with having some certain column in the CSV file, just like the nitrogen, the phosphorus, the potassium, the temperature, the humidity, pH, and also the rainfall. Now, based on these features, I need to predict that which kind of crop is cultivated on your field. Just like the rice, if I see in the labels, it having a column that's called the labels, and in this label, I need to predict this one. So now let us start the coding part here. So you can see here we have the file that's called the crop underscore recommendation.csv. Now using this file, we are trying to building one machine learning model and try to test it out in our Flux applications. And also you can see here one IP on your file. You can also create from here, just click on new, and you can see Python 3. So in this case, you're going to be using here the Jupyter notebook. You can also using here the Google Colab or Python itself. Well, so you can see here our Jupyter notebook is up and running. Now what I can do, I'm simply going to import here the necessary library. First, I'm going to import here the pandas SPD. Then I'm going to import here the numpy as np. So import numpy as np. So pandas is nothing but for loading the data set from our directory, and make sure that you see the file should be in the same directory. So shift enter. Now it is loading this library in my Jupyter notebook editor. Now what I can do, I'm simply going to read it using this pd.read underscore csv, and inside that I need to giving here my path of my direct of my folder of my CSV file. This is called the crop recommendation system. So crop recommendation.csv. Okay. Now let us assign it to the variable that's called crop. Okay. Now it is loaded. The dataset is loaded. Now what I can do, I'm simply going to using here crop.head so that we can see our dataset just like the 5 rows. So you can see nitrogen, the potassium, the phosphorus, the temperatures, the humidity, pH, rainfall, and also levels. Levels means level is given. That's mean this is a supervised machine learning problem. Okay, fine. Now what I can do, let's have a look the shape of our data set. So for that, what I can do, we can using here crop.shape so that we can see that how many row and how many column are available. So it having the 2200 rows, okay, and it having the 8 columns, I mean 8 features, like 1 2 3 4 5 6 7 8, okay, 8 column, and having the 2200, okay, row. Fine. Now let's try to checking the information regarding our data. So let's say crop.info, so that you can see your data, that how your data look like. So you can see here the nitrogen data type is nothing but the integers, and also potassium is also integer. This is also an integer, and those are nothing but the floating point number, because temperature should be in a floating point number, just like 20.87 like that. Also the humidity and also the pH. Okay, and rainfall should be the floating point number. So that's why all the data should be in the integer and also the floating point number. That's mean it having just one column, that's for the levels in a categorical format. Okay, that's mean we need to convert this categorical into the numerical one. Well, now what I can do, we simply go into checking that is there a null value available inside my data set. So let's say crop dot is null dot sum, so that we can check that if there any null value available inside my data set. So you can see that it don't have any null value in our data set in the nitrogen column, in the potassium, and all the columns it don't have any null value. We can also checking that if there any duplicate value is available. Okay, because duplicate value is also affected while I try to building the machine learning models. So let's try to check that. Let's crop dot duplicate. Okay, duplicate. So you can also using here the tab key from your keyboard, so getting the auto suggestions. Okay, you can say duplicate it. Okay, it is automatically given. Okay, dot sum. Is there any duplicated value available? No, you don't have any duplicated value. That's when data set is fresh and clean. If you have the some noisy kind of data, you need to also handle those out. You need to handle the missing value, you need to handle the duplicate value. How can you do that? So now let's try to checking the descriptions. Let's try to describe our data set, the how our data set look like. So you can see it having a count. Okay, so counter full, that's mean you don't have any missing value. You can also check this missing value from these describe functions, and you can see here the mean, the standard deviations, the minimum, the 25% percentile, 50% percentile, 75% percentile, and also the maximum value. Okay, this is how you can actually describe your data set and try to check that. Now let's try to do all the correlations between all of the columns. So for that, what you can do, you can using here CRO for crop. So let's say crop crop dot correlations. It's actually giving me the correlations from my data. So if I check that, you can see here this is the correlations between each column. You can see here it having and p and p, k and can, having the correlation of the each of the columns. That's mean and to and is nothing but correlation is 100%. That's mean you can see here one, and potassium to the nitrogen is negatively correlated. Okay, negatively correlated. That's mean it is important features. It's important features. So what I can do now, we can simply going to store it inside a variable that's called correlation or core. You can also skip it. Okay, you can also skip it because I'm trying to plot it inside a graph. Okay, so that you can see it all, see it clearly. So for that, I'm going to using here the cborn. So let's import cborn as SNS, and then I'm going to using here sns dot heat map. Okay, heat map. So inside this heat map, what I can do, I'm going to using here crop dot correlations. Okay, crop dot correlations, and I'm going to making my annotation should be the true. Okay, annotation should be the true. If you miss my Daredevil Python machine learning library series, I are discussing about the all of the visualization library like pandas or numpy or the matplotlib, which is required to building on machine learning models. Okay, I discussed about that. You can also go on here and try to check that how the cborn library actually work, how the matplot library work, how the pandas or the numpy libraries work. Now let's giving here on color map. Okay, so you can giving here, let's say it having okay, let's try to skip it now. Okay, color map cber, let's try to make it cber should be the true. Okay, true. And now you can see just to white it will showing up because it will take time. Okay, and after that it will show you on correlation matrix. Okay, okay, you can see here by default this is taking the colors, and now you can see it's having the all the correlations that you can see here for the potassium and the potassium and the phosphorus is having the 0.74 correlation. That means highly correlated, the potassium and the potassium and okay, potassium to potassium. Okay, potassium to the phosphorus. Okay, Ca means is potassium in the chemistry, right? And P means is phosphorus in the chemistry. Okay, so that's why थोड़ा mistake हो जाता है यहाँ पर. Okay. Then what I can do now, let's try to checking the value count for my labels. So what I can do, I can using here crop dot labels. Okay, labels or label dot, let's say value counts. Okay, value counts. It will give me the value counts in our uh, label columns. So you can see here it give me the all of the value counts for my labels column. If I see, yep, this is the labels. Okay, label columns. So it having all of the columns is having the 100. That's been 100 of the rice and 100 of the maize, 100 of the jute, like that. Okay, that's been this is nothing but the columns, that how many columns are available in my data set. So what I can do, you can also check that like this way. Let's say crop. Okay, you can also using this like this way. Crop dot labels. Okay, labels dot unique. Okay, unique. Let's try to check that it's working. Okay, it will give me, okay, labels not, it's level. Okay, I can see it give me the all of the unique value regarding my levels, that how many labels are available in my data set. You can also do the count of that. Let's try to also check this out, that is really working or not. Okay, dot value count. Okay, value count is not available here. Okay, we can also check the size of that. Let's try to also check the size. Is it working? Yep, size is working. You can see 22. That's been it having the 22 levels in our data set. Okay, now based on the features column, I need to predict this 22 levels. That's mean this is one multi-class classification problems. This is one multi-class classification problems. So now let's try to check that how our data is distributed. Let's try to check for the potassium. Okay, so what I can do, you can simply going to import matplotlib dot matplotlib. Okay, matplotlib dot pyplot as plt. Okay, then what I can do is simply going to plot it. So for that, you can using here snf dot this plot for distribution plot. Okay, just checking this how our data is look like. That's our data is distributed in the right way, and otherwise I need to also using a mean max scalar. So let's try to using here the crop, and from this crop I'm going to using here the potassium. Okay, not phosphorus, not potassium. Then I'm going to using here plt dot show. Okay, then you can check that how our data look like. Okay, you can see our data is looks like okay fine, but in this case it's just like the outliers, but I don't think this is the outlier and our data is okay fine. Let's try to checking it for also nitrogens. Let's try to checking for the nitrogens. Okay, this is the data for the nitrogens, but in this case is the data is skewed, quite skewed, and our data is not Gaussianly distributed. So hope soon to using here the some scalar so that our data is looks like the following the distributions. So now what I can do is simply going to encoding our data. So we're simply going to encoding our data because we're having one categorical column for the labels. So what I can do, you can simply getting all of the labels same from here. Where is it? Okay, I need to check, do it again. So let's say crop dot label dot unique. Okay, it's give me all the value for the labels. Okay, fine. Now I need to using this one and try to creating a dictionary, and after that you can actually map this out uh, using this features column. So what I can do, we simply going to making this rice should be one, the maize should be the two, the chickpea should be the three, like that, like this way. Okay, otherwise you can also follow this way, this rice, the maize. Okay, this jute, the cotton, the coconut, papaya, like this way. So what I can do, I am simply going to creating one dictionary for that. So let's say crop dictionary. Okay, and what I can do, I am simply going to making let's say I'm going to making this rice should be the one, then I'm going to making this maize equal to 2, like this way, and I am trying to filling all of the things from here to here. Okay, let's try to fill it out, and I'm going to skip the video. So I fill it out, and you can see all of the columns with having, I mean, all of the values is having some unique value like 1 2 3 4, like that. Just mean we're going to convert this categorical features into the numerical. Now what I can do is simply going to map this out using this thing. So what I can do, I am simply going to making this way. Just take crop and inside these labels I'm trying to make it out, or you can using here the same labels. So let's a label equal to crop of the label. So crop of the label, so let's say label, and I'm trying to map it out. Let's try to map, and inside that I'm going to pass here my dictionary, this crop dict. So I'm simply going to pass it here. Okay, now shift enter. Now it will mapping all the columns. So if I try to check this crop dot head and try to check that, now you can see all of the things is converted into the labels. So if you try to checking the unique value for that, it should be the 22 values in my data set. So if I try to check this, you can see here 1 2 21, like this way. Okay, how you try to actually creating here this kind of unique things, it will give you some kind of mismatch value. It actually gave me the unique value, but you can also using here another way that's called the columns. If I see, if I using here this columns, so columns is actually giving this columns values. Okay, it's giving me the columns value. It actually giving the columns value, all of the columns which are available. But when you try to actually using here this unique, it will giving you some mismatch types of value, just having so that how many class or liability is available. Okay, but when I try to do that, make sure that you actually follow this step. I mean, follow this the serials, the how your labels is actually getting from one by one. Okay, rice, maize, jute. But if I see the unique value, it actually is not in a, it's just try to make it in a ascending or descending order, or having some random values. Okay, pick up. Okay, so now what I can do is simply going to checking the value count for each of the labels column. So if I try to check that, just value count. Okay, value counts, then you can see all the columns it having same values. So now what I can do, we're simply going to using here the train test split, and try to split our data set into train and test. So for that, what I can do, I am simply going to first divide our data set into train, test, split. But before that, I need to also convert our data set into dependent and independent features. So that's why I'm going to using here crop, and simply I'm going to using here the drop. Okay, and from the drop, what I can do, I simply going to drop here. I simply going to drop in here which columns. Uh, Having the labels column, I just simply going to drop the label column and try to put all of the value inside my X, and then I'm going to using here uh, from the axis, and I'm going to using here axis equal to 1, and inside this Y I'm simply going to using here crop and my labels. Okay, labels. Okay, level, that's fine. Now X is also divided into the dependent features and Y having independent features. If I try to check this X dot head, then you can see it having with the labels, and in the Y it just having the labels. If I try to check this Y, okay, then you can see it having another columns is 1. Okay, that's fine, that's really fine. Now what I can do is simply going to import here the train, test, and split. So for that I'm using here is from scikit-learn dot model selection, okay, selection, and I'm going to import here the train, test, and split. Then what I can do, I'm simply going to make this X train. Okay, X train, then you have in the X test, then you have in the Y train, and you have in the Y test. Okay, then we're simply going to using here this train, test, and split, and I'm going to passing here my X and Y, and also using here the test ratio that's called test size. Let's giving here 20% of the data for the testing, and simply going to using here the random state equal to 42. Okay, that's really fine. Now what I can do, you can check the shape of our X-train, that our data look like, and this is the shape of the X-train, and you're also checking the X-test shape also. This is how you can divide your data set into train, test, and split. Now what I can do is simply going to scale this out, because our data is just like having some squid value. So we need to make it the distributed is quite well. So that's why we're using here the min max scalar for scaling the features. So for that, what I can do, you can using here from scikit-learn dot processing. We're going to import here the min max scalar. Okay, then we're simply going to creating our instance of that. So let's say mx equal to min max scalar, and after that I'm going to using here x train, and I'm simply going to using here mx dot fit. Okay, fit transform from transform, and inside that I'm going to passing here my x train because it having all of the features columns. So that's why it also fit and try to transform our data set. Now what I can do is simply going to do the same thing for the y train. Okay, so the y train caps lock there. Okay, y train. Now not y train, I want to go it for the x test. Sorry, x test. Now what I can do is simply going to using here mx dot, we're simply going to using here the transform because this is the testing data. So transform, and I'm going to using here x underscore test. Simple. Now if I shift enter, now you can see our data is actually converted into the min max scalar form. I mean scale the features. Now what I can do, if I try to checking this x train and try to run it from here, now you can see it having the all of the values is regarding your data set. It having the range of 0 to 1, just like where it actually convert our data set. Now we can also do the standardizations of our data set. This was the scalar. So now what I can do, we can also do the standardizations of the data set. So for that, I'm going to using here from scikit-learn dot preprocessing, and I'm going to importing here the standard scalar. Now I'm simply going to make it one instance of that. Let's call a standard scalar, and inside that I'm simply going to fit it out. So let's say sc dot fit with our data. We can also using here the fit transforms. Okay, fit transform, transform, okay, transform, and try to passing here my x train data. So let's say x train, and also we need to fitting this out for the x test also. Just shift enter, and we can simply using here the transform on that. So let's try to using here the x test, and let's try to copy this out and pass it out x train, and you can see like that. But here is the problem. When you try to actually using here the standard scalar, make sure that you first doing the fit, then you can do the transform. This is a way of the standard scalar, but in the mean mix scalar you can also using here this fit transform in the same way. In the same way, if I shift enter, yes, it is working. But in my case, I recommend to you how you try to using here the standard scalar. First you feed your data, then after that you can transform it. Okay, so now what I can do, I'm simply going to do the same process. Okay, copy paste, and I'm going to using here this first fit, then after that I'm simply going to transform it inside my same variable. Shift enter. Okay, standard scalar, standard, okay, standard scalar. So that's why it's give me this error. So copy this out and paste it here. X test sc थोड़ा mistake यहाँ पर हो गया. Okay, now it's fine. Now you can see here also is our standard scale our data set. Now we can simply going to apply here our machine learning algorithm. So what I can do is simply going to creating here all the models, the new process, and try to test it out which one actually give me the best results. So for that I'm going to load all of the machine learning model and try to creating here on pipeline. Try to creating here on pipeline. So from scikit-learn, scikit-learn dot linear model, and I'm going to importing here the logistic regression because it having a multiple feature. It's not just like linear regression, so that's why we using the logistic regressions. Then I'm going to import from sklearn sklearn dot naive bias. From the naive bias I'm going to importing here the Gaussian NB, because this is for multiplication, I mean multiple classified types of problems. So that's why. So now I'm going to import it from sklearn dot sbm. I'm going to importing here the sbc because this is one classification tags. Let's try to take some shell also. Okay, so that this can come into the middles. So now from sklearn dot neighbors. From the neighbors I'm going to importing here the k neighbors classifier. Okay, k neighbors classifiers. So here is it, this one classifier. Then from tree I'm going to importing here the decision tree from sklearn dot tree. I'm going to importing here the decision tree classifier, then from sklearn dot tree we're going to importing here the extra tree classifier. Okay, we can also do it here, extra tree classifier, extra tree classifier. We can actually using it in the same way. Now let's make it ensemble. Okay, from the ensemble what I can do, we can import here the random forest classifier. Then also you having a bagging, okay, classifier. Then you also having the gradient boosting classifier. Then you have also the ada boost classifier. Okay, ada boost classifier. So what I can do, we can shift enter and try to import it all of the things. Now I'm going to importing here the matrix also because matrix is needed just like the checking for the accuracy. So what I can do, you can using here the sklearn dot matrix, and I'm going to using here the accuracy matrix. Okay, called the accuracy score. Okay, that's like, okay. Now let's try to shift enter. Now you can see all of the machine learning models is available. I mean, it is imported in my Jupyter notebook. Now what I can do is simply go into creating one pipeline for that in a dictionary and try to using this all of the model and try to checking the accuracy for each of the models. So what I can do, you can using here models. So let's say models, and now inside this model I'm going to using here first logistic regressions. I'm going to copy this one and I'm going to pass it here and try to creating one instance of the logistic regressions. That's it. Okay, Now what I can do now for that next one, I'm going to using here this Gaussian NB, and try to paste it here and paste it and Gaussian NB. Simple. Okay, created. Now for the SBC, what I can do, I'm simply going to copy it here and again here and paste it here. Now let's try to do the same thing for the can-ever classifier. Okay, here is the can-ever classifier. Then we have the can-ever classifier instance of that. Yes, you can do it just like creating one variable and try to instance of that. But here we try to actually using here another types of technique, that how can you creating that if you have the multiple name types of machine learning model, and you try to tracking for all of the models and getting the accuracy from that. You can do it also for the neural network. So let's try to do it for extra tree classifier. Then you can creating the instance of that. Then we having the random forest classifier. Okay, random forest classifier. Then simple, okay, random forest. Okay, we're also creating for the random forest. Okay, decision tree classifier and also the extra tree classifier mostly are same. It will give me the same kind of results. So you can copy this one for the bagging. So let's say paste here the bagging classifier. Then we have the gradient boosting classifier. Gradient boosting classifier. Just going to copy this out and paste it here and try to make it gradient boosting classifier. And the last one is called the ADA boost classifier. It's fine. It's completed. Okay. Now let's try to using here one comma. Okay, fine. So that's our models, and all the models. If a shift enter, it is loaded. Now what I can do, you can simply go into taking all of the values from the models, just like the items, and I'm going to feed to it with our training data. So what I can do for name and also the model in models dot items, I'm simply going to iterate to all the value from here, and after that I'm going to use here model dot feed. Then I'm simply going to passing here my xtrain, xtrain, and also the y train. Okay, now after that I can simply go into creating here on predictions. So let's say model dot predict with my testing data. So let's make it x test. So these are predictions. So let's try to using here y predictions. Okay, now let's try to pass it inside my accuracy score so that you can got here the accuracy score, and inside that I'm using here my y test and also the y predict. Okay, so to give me the predictions of the scores, so we can store it inside a variable. Let's call a score like this way. But when I try to run it out so that you can see our model name also. So what I can do, you can actually give here one print statement and try to using here one f string. Let's say you can also using the f string, or you can also using in the format, but I recommend it. Actually I like to using in the format, but let's try to using the f string. Okay, name of the model. So model is nothing but it's coming from my name. Okay, model with, okay, it having model with accuracy. Okay, accuracy score is printed here just like that. Okay, now if I try to using here the shift enter, and it will load it. Now you can see here how much accuracy I got with my data. So you can see x train and the x test and y test and the y predictions is having a low, but why low? uh, 0.05, 0.07, but why like that? uh, let's try to check that is there any error it is happening here. Why this kind of accuracy 0.25 like that? Okay, let's try to check that what kind of error we got. So well, so I run this code again from the beginning. Hopefully there have been some problem for the mean make scalar, so that's why it actually give me this kind of awkward types of accuracy. Okay, and now you can see it running, it up and running and down. Okay, it's fine, now it's working. Now you can see it got in here 96% accuracy, 99% accuracy, this 96, 95, 98, 91, 99. Okay, 98, 98, and 0.14 for the data boosting. Okay, the lowest accuracy we got for the data boosting. But all of the things we got here, the best accuracy for the Gaussian NB, and also for this random forest. But the Gaussian NB actually gave me the highest accuracy, 0.994545, like that. So now what I can do, you can also getting for the random forest, you also getting here the best accuracy. Okay, so now what I can do, you can simply go into creating here one predictive system, but before that we're also getting one model from that. So what I can do is simply going to taking here the Gaussian B or the random forest. Okay, let's taking the random forest. Your homework is doing it the same way, same things for the Gaussian NB for the naive bias. So what I can do, I am simply going to creating here the random forest. So random forest classifier, and now what I can do, I am making, let's say, rand, okay, rand CLF, okay, and simply going to feed with my data. Okay, but gradient, the Gaussian NB actually gave me the highest accuracy. It you tax to do that. Okay, but also the random forest classifier gave me the highest accuracy also, just like the 99.31, like that. So what I can do, I'm going to using here this fit, and inside that I'm going to using here the X train and the Y train, because I need to creating here one predictive model and try to choosing that which model is important. And also you need to creating here one flux application and to using this model in the flux application also. So fit your X train and Y train. Now we got here the Y predictions. So Y predictions, now you can using here random classifier dot predict. Okay, and you're going to passing here my X test, and after that you're going to checking the accuracy score. Okay, and you're going to passing here this Y test and the Y predictions. Okay, now you can see we got here 99.31% accuracy. I just getting just taking in this one model that's called the random forest classifier. If I taking this one that's called the Gaussian NB, you can also using here this Gaussian NB. If I try to check this like this way, just taking it Gaussian NB and try to replace it. Okay, now you can see we got here 99%, 4 types of accuracy got. Okay, so it's your homework to do that using the Gaussian B and also the random forest, and I do it for the random forest one. Now let's try to creating here on predictive model. So for the predictive system, what I can do, you can simply go into creating here one method. It's called recommend. Okay, recommendations. Okay, now inside this I need to passing here all the value like nitrogen, potassium, phosphorus, potassium, the okay, let's try to do it in another way. So we have the crop dot columns. So columns. Okay, you can see all of the columns. Now temperatures, let's take it. Then you have the humidity, let's take it. Then you have the pH, let's take it. Then you have the rainfall, let's also take it. Okay, now we're taking all the values. Now what I can do, you can simply go into creating using here the NP and try to convert all of the things into inside the array. And now inside this we're going to simply going to pass all of the value. Okay, we're simply going to pass all of the value. So we're going to copy this one and I'm going to pass it from here. Now what I can do, I am simply going to transform it first for the min max scalar, and after that I transform it with the scalar. So for that I'm using here mx dot fit transform dot fit transform, and let's giving here one name. This is the features. So features, okay, features, and I'm going to copy this one and paste it here. And after that I'm going to using here, let's say this is my mx features. So ms underscore, okay, mx underscore features. Okay, that's fine. Now let's try to also do it for the sc called fit transform. Okay, fit transform, and inside that I'm going to passing here my mx features, this mx features, and this is nothing but my sc features. Okay, scmx feature, that's really fine. Now what I can do, I'm going to using here my predictions. So let's say prediction equal to random classifier dot predict, and inside that I'm going to passing here my FCMX feature. That's my transform features. And now inside that I have to reshape it. So reshape it, reshape it with a 1 comma minus 1, so that you can got here one value in the prediction. So let's try to return here our predictions. So return prediction from the 0. Okay. Okay, that's our recommendation function is ready. Now what I can do, we can simply going to take some value like for the nitrogens, the potassium, the phosphorus, also for the temperatures, and also for the humidity. Then let's taking the value for the pH and also the rainfall. Okay, also the rainfall. Fine. Now let's giving here some value. Let's call 40. Let's taking it from here. Okay, here. Okay, let's set crop dot head. Okay, so let's taking, let's say make it 90, let's say 42, same things we can give. Yes, let's give here 42 and 43, and temperature is nothing but this one. I'm just going to copy this out. This is really working. I don't know it is working or not, but make sure that it is really working. Humidity, then pH, and also the rainfall. Okay, you can also give this rainfall or the pH in the form of the from the integer. You can also do this like this way. So let's start giving here temperature, like say 14.0. Okay, like this way. Let's say humidity, let's say 20, or let's say 22, or pH, let's say pH 6.5 is okay. 6.5 or 7.5, let's make it 7. And rainfall, let's make it 200, 2000. Okay, like this way. You also giving it without the floating point number. You can also give it in an integer in the from the integers. So what I can do, I'm simply going to using here these recommendations, and I'm going to passing here all the value for the nitrogen, the phosphorus, and also potassium. So what I can do, I'm simply going to copy this out, and I'm going to passing it out here. So it gave me one predictions. Let's call predict. So let's try to check that which kind of prediction we got. So predict. Okay, and array is 3. Array 3 means which one? Yep, it's called jute. Okay, jute. Okay, based on this temperature, the humidity, and all of the things, it'll give me the prediction as a 3 jute. So let's try to using this one. Temperature this one, and humidity this one, and the pH is 6.5. It's not greater up to 7, and rainfall is this one. I'll also go to the chemistry and biology. Okay, thought I just give me the 3, having some problem on that, but yeah, it's really working very fine. Okay, so now what I can do is simply going to dump it out. Okay, dump all the value in a pickle format. So what I can do, you can simply using here import pickle, and then I'm going to dump all of the things. So it's called pickle dot dump, and inside that I need to give in here my classifier. That's called, okay, this is nothing but random forest, right? Random forest classifier. Let's try to make it again. Okay, first time it may be imported just like the Gaussian distribution. You can also go on here and try to run all. It will running from the beginning. Okay, so what I can do, you can using here the random classifier. Then after that I'm going to using here the open, and inside that I'm going to using here the model dot pickle file, pickle, and in the form of wb. Okay, wb. Okay, hopefully to give me the accuracy. Okay, to give me the accuracy, just try to running all of the models. Okay, then we can do the same thing for the min max scalar, and also min max scalar. So let's make it min max scalar. Okay, then this is for the standard. Okay, a standard scalar, it's a standard scalar. Yes, sir. Okay, in the right mode. So let's just shift enter. Now it will store it inside my working directory. You can see mean max scalars, also model pickle file, that's standard scalars. Okay, and this is nothing but one random forest classifier. Okay, let's try to make it mx, and this is sc. This is not the random forest classifier. Okay, don't do this kind of mistake. Okay, so this is mx for the mean max scalar, and sc the object of that instance of that, and this is the sc. So if I try to go on here again and see that, you can see mean max scalar, this model pickle file, and standard scalars. Well, that's really fine. Now what I can do is simply going to using this pickle file and try to predict it that which kind of crop is cultivated on our field. Okay, now let's try to building here our Flux applications. Okay, let's go on here. Well, so in the right side, you can see here all of the pickle file, mean mix scalar, the model file, and also the standard scalars. And also you can see here, there is a file that's called app.py, and also a folder that's called templates, and also one folder called static. So this is the code for that how can you building one Flux applications using Python. So if I go inside this template, you can see here there is a file called index.html, and this is nothing but my template file. So in this case, you can see here it's just having one title and just having some box. Okay, you can see just having one box for nitrogens, the phosphorus, the potassium, the temperature, the humidity, and also the pH. Okay, and also for the rainfall, just having all of the columns just for one input box here it can taking the input from the users, and when you click for the submit button, and it will go for the prediction, and it will recommend here the result, I mean which types of crop is going to cultivate it on your field. Okay, just simple just as it is. You can see just having one form, and inside this form is having an action called predict. Okay, we'll call this predict actions from our app.py, and method is nothing but post, because we're going to posting on the data on our from our model and try to getting the predictions from our model file. That's it, just having some input box and one submit button and one for result. So if I go inside this app.py, you can see first we import here from Flux, we import here the Flux, then request, then render template, because we need to render in the template from our templates folder. Then we have all of the models file, and also import here numpy, pandas, scikit-learn, and also the pickle format. Then what I can do is simply going to load here all of the files like model file in this model variables using pickle.load, and inside this we're using here the open method, and inside this open method we give here my mode is nothing but RB. RB means read mode. Okay, then we have the standard scalar and also the mean max scalar. Okay, that we see in this crop recommendations using machine learning IPN file that we already discussed about before. Well, now what I can do is simply go into creating here our app using Flux, and creating here give here underscore name. Then we're creating here our initial route. That's mean for the initial it will giving you your index.html from your render template folder. Then we have one route that's called the underscore predict. Okay, and you can see not underscore, it's a black slash predict. If I go inside this index.html, now inside this form you can see the action is nothing but predict. That's mean when a user clicking the button called submit or the get recommendations, it will go to these recommendations inside the predict method. I mean it will automatically calling this predict route in your applications. Okay, that's mean when you click in this button submit, and it will taking on actions, the action is going to the predict. And method is nothing but post. Okay, it's not a get method. Get method is nothing but fetching the data from your database, but it posting it. Then we're creating here one method that's called the predict, and it in taking the data from my form that's called request.form.nitrogens. If I go inside this index.html, then you can see we having some id column for rainfall and also the ps. Okay, id is ps here, it should be the ph. P should be small and A should be the capital. And let's start making this one also pH. Okay, just taking all of the things from here, and you can see pH. Okay, and also make it pH like this way. Okay, then you can see taking the value for the phosphorus, then potassium, the temperature, the humidity, pH, and also the rainfall. If you go inside this index.html, you can see id should be the match, and also name. Okay, and also the placeholder, you can the name it is showing up, and having a class, and also the required step is nothing but 0. Okay, that's when it having one counter value, you can count increasing this value when I go to the here. Okay, so if I go inside this app.py again, then it will taking all the value like potassium, the nitrogens, the temperature, humidity, pH, and also rainfall. Then what I can do, it can simply go into creating here one feature list. It can creating one feature list. So that's when you simply going to passing it inside one list, and after that, we're simply going to pass it inside one numpy array because we need to convert this feature list in the form of array. Then it also reshape it because we are trying to predict it. Okay, and we have just one single predictions. I mean, with having just single nitrogen value, single phosphorus value, single potassium value, single temperature, single humidity, single pH, and also single rainfall. That's why this is one single predictions. Okay, and then what I can do is simply going to transform our data in the form of min max scalar that we do earlier when I try to building the machine learning model. And we're simply going to pass it inside our standard scalar, and after that we're simply going to predict it out. Okay, that's it. And we got here one predictions. And also you can see here we actually creating here the same dictionary that we do in our Jupyter notebook, just for rice, the maize, the jute, the cotton, all of the things. Then we're simply going to creating here is the predictions. If the prediction zero is inside this crop, then we're going to passing the value from our crop dict so that we can get here some value. See one thing here, if I go inside this crop recommendation using machine learning file, then you can see you actually creating here the dictionary in the form of like that. Key is nothing but rice and value is nothing but one, because we converting this categorical feature into the numerical feature. Now we have to do it the opposite side. I mean, transform the data. That's mean that's mean we have one value as a numerical value. Now we need to convert this numerical into the categorical. So that's why we're simply going to first pass here one, then we pass here the rice. That's why. Then we pass your our prediction inside my dictionary, and dictionary is actually give me one result. Okay, that means this crop is best to cultivate in the right year. Otherwise, sorry, we could not have determined the best crop to cultivate in your land. Then after that, we loading and try to render in this template. It's called index.html, and inside this index.html, we passing here our result. If I go inside this index.html, now you can see if the result is coming from here, then we're simply going to show it inside one card, which are having one file. It's called the crop.png, and this is available inside my static folder. If I go inside this static folder, it having a file name. There's a crop.png. This is the file. Now what I can do, I am simply going to run it out. Just go on here and try to run it out. Now it will running up and down, and it will open in this file in our browsers, local browsers. Now you can see it running on our local browser. So what I can do, I simply going to click here the follow the link. Okay, so you can see here this is our application, crop recommendation using machine learning and crop recommendation system. So let's go on the full screen mode. Well, so you can see here it having taken the input for the nitrogen, the phosphorus, the potassium, the temperature, humidity, pH, and also the rainfall. Now you can see it having also one icon, which one you can actually giving here the value, and a step is nothing but zero. It's coming from the zero. So you can also using this arrow sign to increase or minimize your value. So now let's give here some value. Let's say 40, let's say 50, let's say 50, some random value I'm going to give it here. Temperature, let's say 25. Then humidity, let's say give 20, let's say 200. Okay, ps, let's say giving here 7. And okay, let's make it increase, let's say 5.5. And rainfall, let's say 100, like this way. Now let's click here to get recommend, and you can see recommend crop for cultivation is grapes, is the best crop to be cultivated right here. Well, so this is how it actually work. Okay, you can also giving here some random value also. Okay, let's giving here some random value. Temperature, let's say 40 degree. Humidity, let's say 200. Okay, let's give it here 7. Rainfall, let's say 250, and try to click it to get recommendations. And you can say apple is the best crop to be cultivated right there. This is how the crop recommendation system actually work, and you can get the all of the code in the GitHub link in the video descriptions. So you can just go on here and try to grab this out. But my request is to please watch the video from the till the end, so that you can know that how what actually happening here, and how the machine learning algorithm actually work, and how can you handle in the all of the stuff like missing value, or how can you handle the categorical value, and how can you creating this kind of flux application from the skirts. Coding, fetching the code from the GitHub is okay, fine, I know, if you don't have any time, but my request is please learn from that. And even though when I tried actually making this out, it's also taking time for recording video, for editing, all the things. So I recommend you that please watch the video till the end from the first, then try to building it from the one. Don't see the GitHub. Don't go on the GitHub. First, do it on. If you have facing any problem, just comment on here. Comment on the comment box. Otherwise, you can fetch the code from here. Okay, that's it for today now. Hope you enjoyed the tutorial and make sure to subscribe to the channels and don't forget to hit the bell icon. And I'll be back with the other tutorial. So till then, take care and bye bye.